with our branch and take this event for undertaking us through the implementing process safety. David is a triple chartered member, so with a vast 30 years of experience. And when I say triple chartered member, so he's a chartered engineer and he's a chartered professional in terms of safety as well as environment discipline. So his experience is measured into the international companies and operations where he is supporting for the strategic issues related to the risk, safety, and emergency management. David is currently the IOSH Hazardous Industry Group Chair, and he's also involved in different projects, including business change and transformation, hazards and risk analysis, incident investigation and root cause analysis, and development and improvement of safety culture. With his experience, he is a regular speaker and he is giving presentations on a different safety aspects and helping the members for their potential growth. So with this, welcome David for this IOSH Oman branch event, and over to you, David.
Thank you, Nilesh. Let me try and bring my slide back up, which the one thing you didn't say was that I am not technically competent, but I believe that that should now be up on the screen. Can you see that, Nilesh?
Yeah.
That's great. Welcome, everybody. As Nilesh said, I'm currently chair of the Hazardous Industries Group. A little bit of an odd group in the fact that it's actually quite hard to define hazardous industry. It's very easy to put us into a group of oil and gas, chemical, petrochemical, which is a strong part of my background. But actually, when it was originally started, it was due to mean much more than that. It was to look at supporting any member in an industry where, if you like, nature of their work or their exposures lead them to have to handle any form of higher than normal, higher than background hazards. So you can see that electricity, power generation, renewables, every industry just about covers within this. But obviously we're borrowing quite a lot across those industries. And one of the things I want to bring out in this presentation is that I think in reviewing process safety, there's an awful lot of work being done in the specialist area, particularly in the oil, gas, chemicals area, that can be shared across other industry groups. And so what I want to do, when I asked about who is going to be joining us today, I was told that I'm going to get some people who are very knowledgeable on this, some to whom this is something they're working on and learning, and others who perhaps have not had any exposure to it, but are interested to see how they could apply some of the tools, techniques, and learning in their own particular area. And so whether it's manufacturing, construction, or background, that's what I'm going to try and aim to do in this talk. Now, Nish has given me around 50 minutes, and then we can have a Q&A. Any questions that you want to put into the chat or questions area will be monitored, and we'll try and get back to you on everything that's there. Already noticed the standard question about will the slides be made available, and yes, we can make those available afterwards. So, do you know I've just tried to move my screen forward and it doesn't seem to want to go. Oh, there we are. So what am I going to try and cover today? It's always wondering when I push buttons and nothing happens. We're going to look at tools and techniques associated with process safety and explain a little bit about where it comes from and what it is. And I'm going to be very controversial in my views about what it isn't and what it should be and the things that we should be doing. So treat everything you hear in this presentation as my thoughts, not IOSH's thoughts or even the Institution of Chemical Engineers or anybody else's. Tools and techniques, we're going to look at pitfalls and problems, which I think is a good thing to look at. And if you've got any, I'd love to share them towards the end. I'm going to try and cover what I think good should look like, and then end with where I think the future should be taking us in this particular area. So let's start. I'm going to start by asking you, as I talk through this presentation, to think about two very, very different types of incidents. Process safety is being driven by case studies. It's come out of major events, multiple fatalities, the disasters that we learn of, we read in the papers. failures, and we, all don't want to have anything to do with it. So the first one I picked on is the Deepwater Horizon, mainly because nearly all of us know about it. A state-of-the-art drilling. This was a state-of-the-art rig. It wasn't something that had just been pushed in. It was drilling a deep water well into a high pressure reservoir. And we all know that there was a blowout in 2010. 11 deaths in over 87 days before they could cap that well with massive environmental impacts. If we look at all the reports and the studies into it, they acknowledge a number of root cause problems: failure of safety barriers, lack of knowledge relating to the status of the well, poor decision making. It challenges in the report to the president, which I've quoted underneath, which is the final inquiry report: poor decision making, poor response planning, and weak regulation. We can pick on many things. And in fact, I've quoted here one statement: the immediate causes of the well blowout can be traced to a series of identifiable mistakes. That's true of many, many major instances. They reveal systematic failures, which is another interesting thing. It's rare that we get very, very nasty events occurring when there aren't multiple elements of causation, that there are failures that are not single point failures, but they can be traced through root cause analysis into many features. This report hits the risk management, systemic failures in risk management. I would actually challenge them. When you're on the rig and you've got a well that isn't under control, it's not risk management. The risk of a blowout conditions they put in place was one. It was a guaranteed probability was one. You weren't going to avoid it. The problems there were that they thought the safety barriers were operational. They thought they had cement. They thought they had killed well. This is right at the very end of a long period of months when they've been drilling this. They've gone through far more dangerous periods. This should have been a very safe operation. Shut the well off, unlatch, move on. They were in end of project mode just about. But it raises a lot about the safety culture of our industries. And it raises questions that we want to look at. So we could concentrate on these. But I want to take you into another area and get you to ask similar questions. And the one I've picked on was, I thought I'd start looking at construction. And in the UK, a number of you will have heard of the Grenville Tower fire. This was a fire on a block of flats in. It was a large block of flats, I think about 70 meters tall, if I remember right. Designed in the 1960s, built in the 1970s, and then later refurbished to bring up to more modern standards, well, environmental standards. And on the 14th of June, 2017, there was a fire. And the fire started in somebody's flat, and it started, I understand, on a washing machine. Now, that should not have led to 72 people dying, but it did. Now, when I go through the tools and techniques and raise the questions that we go into on process safety, why aren't we applying some of these techniques and ideas and tools to these areas? What happened? There was a failure of safety barriers. The fire was allowed to spread. And by safety barriers, we could be talking about fire doors. We could be talking about protection of conduits, protection of the fire moving into the external cladding, the properties of the external cladding allowing propagation. There was a lack of knowledge of the responders to the nature of the threat, in particular the speed, and what to do and how to communicate and how to evacuate a block of flats with a single stairwell exit. Again, poor decision, poor response planning. And in the Judith Hackett report on it, weak regulation, confusion of the structures, and there are so many linkages. And Judith confirms that we must begin to think about buildings as systems. I would argue we need to think about work as systems. We can consider different layers of protection, in this case, to make the building safe. So I hope this resonates with you. The next time you look at a block of flats, a high-rise building, or you walk onto a process plant or operation, just have a thought through some of the things I'm about to say. Process safety, as I said, evolved out of major incidents, and its evolution has not been smooth. In part, there was a desire and is a desire to separate it from safety. Now, this slide I've taken from OSHA, and most of you, a large number of you know of America and OSHA. And if you go online and you search OSHA Safety Management Trainer, you'll get a free pack to download. And one of the slides in it is this. So I hope they don't mind me using it and abusing it. You can see the principle here. They want to tell us that severity is a big part of what we're looking at. They want to separate it from what they've termed personal safety, routine health and safety, if such a phrase even exists. Now they've separated. They said we should look at personal safety and we should need to look at process safety incidents. And you'll find this in a lot of documentation. That process safety is different. And to a certain extent it is. It has its own tools, it has its own techniques. It needs focus, and this is why they wanted to separate it. They wanted to get buy-in. They wanted people to say you can't just lump it into one cauldron and stir it. And in fact, if you look back through a large number of major incidents, you'll find that the sites themselves were promoting personal safety, the routine safety elements very, very well. And one of the tragedies of Deepwater is that they actually got an award that night for their low levels of accidents, for the routine problems, the lost time incidents. They were top of the heap and they were getting their award. And of course, the message is, but you can't get that because you're not focusing on process safety. You can't put all your elements into one basket. My point, though, is that you can't have process safety unless you have good safety management, unless the routine background system of safety culture, behavior, of understanding risk, of putting the procedures in place, of maintaining standards, of looking after it. This is the foundation on which process safety needs to be built. It takes the hard yards for the higher risk, the lower frequency, high consequence events. But if you go back and read about Grenfell Tower, you'll find that there was no safety system. It was a failure. Everything that you and I would think should happen, from the fire risk assessments to the protection of the people, to the fire doors, to the evacuation systems, they're not process safety. They're personal safety. Let's get those elements together. But if by focusing on process safety we can improve, which is what Grenfell should have, it should have challenged those higher risks. It should have looked at the consequences. Then maybe we can all learn from each other. So this is what you find if you do a documentation search, that process safety differs from occupational health and safety, the personal safety, because of mechanisms of causation, scale of potential, and the fact that it is, by virtue of being process driven, focusing on engineering and design. But don't we have engineering and design in manufacturing and construction, in hospitals, in aviation and other areas? Of course we do. And so these elements should all dovetail across. And they went on. A couple of key factors I pulled in to identify causation of process safety incidents. A failure to distinguish the need for different approaches to manage hazards. There is a difference, and this is the difference between occupational health and process safety. And occupational health looks at events that have a greater likelihood. Yeah, we see them, we pick them up in LTI accidents, we see the reports, the near misses. And therefore, we can do things about it very quickly, but they lower consequence. They tend to lead to injury, sometimes severe individuals, rather than large numbers of people on the plant and associated with it. And there are assumptions that strategies for managing personal safety are similar to create safe conditions and processes. So there's originally a fear that if you had good personal occupational safety, then you were okay. The plant would be safe. Now, it's not true. But my point is reverse the argument. It's no good having a safe plant and not having good occupational safety. It doesn't work that way either. So putting all your eggs in one basket definitely counts. And certainly the metrics that we were using and continue to use for personal safety do not provide the information we need on the status of process. So we can look at definitions. This is one from Australia. Let's move around the world. We started with America and OSHA. This is very similar to the UK Institution of Chemical Engineers, HSE. It's about managing the integrity of operating systems by applying inherently safer design principles. We know this. If you're dealing with a large volume of highly flammable material at very high pressures, then obviously you need to have specialist knowledge and take very, very good precautions. It deals with the prevention and mitigation of incidents that have the potential for loss of control of a hazardous material or energy, and so on and so on. And it leads to extensive property damage, environmental impacts, and so on and so on. Now, there's two, I think, key themes to process safety. The one I'm going to follow is very much, if you like, what's inbred into me, because I come from the UK. So it's the HSE, it's the view of COMA, Seveso, it's the view of risk being a driver in these areas rather than regulatory prescription. But let's not forget that OSHA has process safety management. It adds the word management, and it is a management system. And for those of you working with or exposed or balanced with OSHA-based systems, you'll be well aware of this. It has 14 elements. It's driven towards highly hazardous chemicals, and it applies the processes to certain quantities of those chemicals and certain sites. Now, I was in Texas in 2013 when the ammonium plant, West Texas, went up, killing, I think, 15 emergency responders. And I've written separately on the timelines, the timescales, and the issues. And here we have a tragedy of hazardous materials, which very few people knew what the hazards were. Yeah? And you think, what? This is in a city or a state where it has a record of one of the worst ammonium nitrate disasters when it lost a ship in Galveston that blew up. So we have no knowledge. Knowledge is something that is very ephemeral. Those of you who've ever read Trevor Kletz, who was, I guess, part of my university learning, it shows how long ago I went to university, where he wrote that organizations have no memory. They don't have a recall, we forget. And so part of the theme as we go through this is how do we handle information? How do we capture it? The elements of OSHA, you can see them here. Process safety information, hazard analysis, hazards, key point of this, operating procedures, training, contractors. Who doesn't have fun with contractors when you're trying to maintain safe systems? Integrity, mechanical, management, change, hot works. They're all solid elements that are common to all elements of process safety, whether you pick up Australian guidance, UK guidance, anything in the Middle East, Singapore, and so on and so on. They're all there and form part of this system. In my language, this is my model that I carry around with me. I think of it as being technical. There is a very, very technical heart to this, but nobody can know everything. What I mean is I'm relying on technical expertise. I, as a facilitator, need to know the questions to ask. I may not know whether the answer's right or wrong, but I can look at it later. But I need to know there's a technical heart to this. There's an operational control. There's no point me developing the best process plant in the world and finding that my operators are not competent to operate it. But it's not operational just in terms of operators. It's down to maintenance, management processes, procurement, HR. Every element of an organization fits into this. The management processes, the procedures, the people. I have a tendency to feel that process safety ignores people. It moves too far. As engineers, it's much nicer and easier to deal with calculation than it is to deal with somebody who wants to tell you that something's wrong. And they don't particularly like you either, because you're not listening to them. So It all comes together and it fits around the background of hazards and communication and resources. And time, I'm going to come back to time later, because that's something that really does bug me. I'm sure Louise is also keeping an eye on time, because I tend to talk too much too slowly. Let's have a quick look through the tools and techniques. It starts with, remember I put up on IOSH, hazard analysis. Easiest thing in the world to do, isn't it? I don't think. If you get a group of people together and say, what are the hazards? However many people you'll get an equal number of views as to what a hazard really is. Process safety tries to say it's a substance or condition. It's a fundamental, it's something that you can recognize, you can feel it as a property, a component, an element about it that you recognize. Whether it's chemical energy, process, pressure, temperature, whether it's the biological radionuclides, whatever you want, radioactivity, it has a property you can see. And it tries to take it back to the bottom. It's a condition which can cause injury or harm to people and the environments. And fundamentals are chemical, physical properties, substances, or systems. Now, this is fundamental because actually, if you start too early in the training and you decide that something's a hazard, when actually it's an outcome, or it's a process, or it's an incident, it means you don't go back to the beginning. And if you don't go back to the beginning, you can't ask the right question. So slip, trips, and falls are always great in occupational health and safety. They're not hazards, not in this language. The hazard in those circumstances is gravity. It takes it right back to that very beginning. If you don't have gravity, how many astronauts suffer from slips? I don't know the answer to that. But I guess if they float, they don't have as many as I do when I trip over the carpet. But do you see what I'm trying to drive? You know, if I look at a car and I drive a car, the fuel is a hazard. But the brakes aren't, the crashes. It's the speed, it's the energy, it's the momentum that becomes the hazard that I introduce. And if you look at OSHA, they recommend a range of techniques. They also address where they should be applied. And they start to bring in human factors. And they're saying that hazard analysis is a team process. It isn't about me or you doing it. It's about bringing people together. It's about capturing knowledge. So there's a range of tools. What do we look at? I'm not going to go through these. It's too short a talk to even do this. We can do a high-level hazard screening. What do you think the hazard is? Well, I don't know. What about you? Let's brainstorm. We can do a more structured process hazard reviews. Hazard identification, HAZOP, one of my favorite tools and techniques. Numbers of days sitting in on HAZOP studies. Hazard and operability, a great technique. Again, developed in the 60s. Kretz was part of a team that did it, and it's very, very interesting. Identify the hazards, pressure, temperature, whatever, and then ask what changes. What can lead to a change? How can it change? What are the operating conditions that prevent it? What are the mitigation factors? What do we need to reduce it? You strip it down, very, very detailed reports. If you've never come across it or see it, look at it. Look into it and see what's there. Its strength is phenomenal in terms of early design input to process plants. Its output, though, I have a lot of questions. We can look at event trees and fault trees where we're bringing up a whole series of issues to a top event. What causes the release? What causes the fire? What causes the explosion? What has to happen? What are the steps and what are the stages? And when we've got them all together, we can start to apply probabilities and estimate risk. Event trees as we run forward. What happens if I get a release? You know, what is going to happen? Will it get detected? Will it find an ignition source? Will we get an explosion? And so on. We have consequence and dispersion models. We have frequency and number curves to look at how many people will be injured, killed, damaged, and so on, and so on. I'm going to come back to hazards in a minute. What we're trying to do in the tools and techniques is identify from the hazards what the safety critical elements need to be. We need to look at high quality safe work, permit to work systems, togging, logging, all of these form part of what I described earlier as the system. There's no one element, there's no one safety barrier. There's a multi-element shift. What went wrong on Deepwater Horizon was they managed to override just about every safety barrier that should have been in place. And of course, they should have had better information. Operation of a pressure relief valve with pressure vessel at the required conditions. Well, of course, I've got a pressure vessel, I've got a pressure relief valve. How confident am I it's going to work? Pressure relief valves don't always work. How confident am I, if it does work, that the relief system that it vents to, or the area it vents to, is a safe area in which to vent? 1,000,001 questions that can come through. What I'm trying to do is identify, for me, on my process at this point in time, what are those safety critical elements? You're sitting on the 20th floor of Grenville Tower. It's the night there's a fire in a flat about, let's say, 7, 8, 9 floors beneath you. What are your safety critical elements? Because that building should have had, whether it's the fire escape, fire doors, the fire alarms, the communication system, they're all safety critical elements. Sit in your car. What are the safety critical elements? I'll put brakes in as one, but let's move on. Safety factors. This is where we're starting to move to. But you'll see not all of these are engineering and technical. Inadequate training. I don't want operators who have not been trained. And one of the big problems on Deepwater Horizon is they didn't know what they didn't know, as Rumsfeld once said. They didn't have the knowledge to understand the conditions that were in that well at the time they were making decisions. Competence, knowledge, lack of supervision, safety briefing, safety management, impact of targets, pushing people to get things when they can't do it. All these are part of all major incidents. We can see them, but they very much share a linkage into occupational health and safety. That's what I mean. OHS safety is a foundation stone of process safety. Let me look at it another. What goes wrong? We've got lots of reports. We've designed our new plant. We've done our hazards. We've done our hazard studies. In the UK, we'll have developed safety cases. We'll have paid consultants to do detailed risk assessment. I can tell you what, there's no shortage of information. We've got lots of information. So I have a brand new plant. It's just been commissioned and somebody hands me the keys. I'm not sure if any of you have been in those situations, but it's often a lot nicer than running a plant that's 35 years old. Well, is it? Let's come back and look. I've now got the key to my shiny plant. What could possibly go wrong? Well, the first thing is it changes from the day that I take it over. And how confident am I that what they've handed over is what was actually designed? Because actually, there's quite often changes and management of change during construction. And then they'll tell you, well, we haven't quite finished those little bits, but they're not safety critical. They'll come on in the next week. So I'm going to look at 4 areas. Time, which I said earlier I was going to come back to, risk, awareness, and governance. Perhaps it's because I'm getting old, time becomes a big feature. I think it's the number one pitfall in process safety. Whatever you read, wherever guidance you go, you're not likely to come across anything that tells you think about time. So let me move you forward from my nice silvery plant that I've just received the keys for. It's 5, 6 years down the line, or maybe it's the 35-year-old plant that I'm now operating. My first question when I'm ever invited to a site to do anything like this is, are you still operating it to the original design? What were the assumptions that were made in that hazard that you've now changed? And have you, in changing them, updated that risk hazard? Have you done the hazard again? Have you checked the assumptions that were made? And I'm yet to go, I think, on any plant that's about 6 or 7 years old and find that it actually is exactly the same as the HAZOP team believed it would be. We continually change our design. If it's oil and gas, we bring in new wells, we bring in new liquid, we do all sorts of things. Doesn't matter that we do it as long as we manage that change properly. How do we know that it's okay? Because my HAZOP is now 6 years ago. And I can guarantee you, if I said to anybody, have you read the HAZOP? Nobody would. If you're part of the team there, you have the knowledge. But it's so detailed, it's so full of information, you can never really go back and pull out what is important. I once did a project in the health and safety exec, looking at how you could audit a HAZOP. And that was really quite interesting. We did come out with a whole set of criteria about that. How do you know your HAZOP is right? How do you know it's being implemented? So from the very word go in the project, time is important. If you don't capture the information right at the start and have a system that maintains it, updates it, communicates it, it gets forgotten about. We're too busy operating the plant. We don't care why it was built or what it was done. Modifications are made. New equipment is added. Often efficiencies are increased and improved. All of this adds factors to the hazards. And at the same time, the plant itself is getting older. It's cycling. It's going through more processes. The people, they come, they go. You lose knowledge every time somebody leaves. And it's a pitfall to process safety. Risk. I believe the language of risk is vague, regularly misused, and we all have our same views. I mentioned hazards. Getting back to the start. Risk exists in various domains in its own right. So procurement don't actually want to buy that oil that you wanted for the compressor because they've got a cheaper option. Trouble is that cheaper option isn't quite to the same specification, but no matter, it's close enough for operators. And that's not the first time I've come across it. So there isn't one part of your business that shouldn't be engaged in process safety and have knowledge of it. They don't need to know everything, but they do need to know what their part is in ensuring that the systems that you want to be safe remain safe. Risk, unfortunately, is not simple. We start on the first lesson is harm, probability, risk. I have an incident, I can calculate the probability of it happening, and I get this magic thing. But often I can't calculate it because it's too complex, takes too much, well, it's too difficult, takes too much time to get the data. So I put a risk matrix together, then I've got red, yellow, green, or any variations of numbers I want, and I stick it there. And nobody likes it, so we move it down. But risk isn't like that, because any hazard, multiple paths to harm. Each path has a risk. Each risk has its own probability. And as you map those out, you get complexity. Because if I do something, you do something, somebody else doesn't, then you're starting to influence it. We like to deal in simple. We've got to, because we can't spend all our life pontificating about it. A decision has to make. Risk introduces uncertainty, which we don't know. If we try to calculate, what are the uncertainties? When was the last time you saw a risk assessment that actually clearly stated it's based on these sensitivities? These are the uncertainties within it. We think this is the spectrum of risk. Over to you. You don't get that, do you? You get guidance. It's high, it's medium, it's low. It's 1 times 10 to the minus 4. It's a probability. Oh, well, okay, guys. It's a figure. Tell me the basis. Tell me where it's going. Because risk does not produce an answer. Yet most of our managers and executives and directors believe it does. It doesn't. Risk is comparative. If I say I want to do A or B and I do a risk assessment, then it should guide me as to whether I do A or B, because it will tell me the relative risks associated with that, the difference in the feeling. And if I say B is a lot more expensive than A, then I've got to have a high risk difference before I can afford to do B. But in doing that comparison, quite often I can understand what other precautions I need to put in place in order to manage that risk. So in my view, I told you I'll be controversial. Risk is no use in giving you an answer, but it's very, very good, or should be, at giving you a steer on which decisions can be made. And the other one is that most people seem to forget that this thing called risk is purely a statistical function. Once we bring probability into it, we're saying, what is the number of the horse that's going to win the 330? It is not absolute. It can't be absolute. But don't let me hit it. I am a fundamental believer in risk and risk management and risk assessment. It's absolutely critical. Just understand what you're getting, because it's often not what it says on the tin, as the UK advert says. It's something else. You're getting an answer to a question you didn't ask. And finally, one of our pitfalls are people. Unfortunately, there's always people involved in most incidents. Therefore, I have to conclude people are a problem. We have too much or too little information. I've said massive amount of information has up, you can't pull it out, can't use it, and it's time limited to the time it was done, which is a shame. Knowledge is held by too few people. Now, one of the things about process safety it does drive people is to try to get everyone involved. You've got to get it. You can't know everything. You don't have that experience. You have to bring them in together. And access to information can be difficult. Competence, unfortunately, is transitory. If I'm competent today, am I competent next week? In other words, if I stripped down a compressor 2 years ago, can I still do it now, 2 years later, when I've been sent away, had COVID, moved jobs and come back in a different position? How do you maintain competence? And risk, always remember, is dynamic. If you walk through an area and judge the risk, it's not going to be the same an hour later. Governance was my last point. Process safety has to be owned by the whole board. Again, you'll find OSHA, even in the HSE, they say nominate a board member to have responsibility. Sorry, no. Nominate the whole board to have responsibility and have a focal point. Yeah? Put somebody responsible on the board for the information flows and the communication, but don't make them responsible. Make the board responsible. Everybody has a role in this. It's too big for one department. And I strongly believe our role as safety professionals is as facilitators. And it takes us into this process, into this plan. And we should be having conversations one-to-one with these individuals who know. The second, well, one of the most major pitfalls is that I believe most audit and inspection programs are not fit for purpose. I hate to say it, even if you go to the IOSH auditing standards, I'm questioning whether they actually drive well enough into the technical areas for process safety. They can be adapted, but do they do it? One of the good things that's come out of process safety is the need to identify what they call leading indicators. You can't wait for the plant to go bang and cause massive amounts of damage and then investigate and say, well, we won't do that again. It's bad enough when somebody has a trip or a fall, but when you're starting to kill multiple people, that's not good. So we want to move from lagging. So we want to move from things that fail. My pressure relief valve didn't pass its test when we took it off the pressure vessel. So if we had a problem, it wouldn't have, and then the pressure vessel could fail. We don't want to know that after the case, do we? We want to know it before. So what are the indicators alongside our systems that are going to tell us that things are not as good as they should be? And one of the big drives, I think, to developing techniques for leading indicators is fundamentally a powerful tool within process safety. And my be in the bonnet, don't forget about the influence of time. So I'm just going to quickly have a look at what I think good should look. And this is difficult because I balance, do I stay high and how detailed do I go? So I've probably failed to get to the right point on that. I believe it's an all elements approach. These are my elements. As I said, OSHA had 14. These are mine. I gave up putting additional ones in because I ran out of opportunities to draw ovals. But seriously, it's optimization across all these. Competent people, risk management, which I include the hazard identification, effective procedures and systems. And effective procedures are not good procedures that are written. They're good procedures that are written and implemented. People can apply and do apply, yeah, and they're living documents. That it is teamwork. It's not about an individual going out and changing the valve correctly with the right permit, yeah, and the right isolations and the right tagging and completing it. It's going back to Grenville Tower. It's the fire risk assessor going in and doing his job properly and communicating with people when he didn't know what he should have known or found out and asked the awkward questions. In process safety, how do we control activities? We've got to control activities. We can't have people just going off doing what they want when they want. Yeah? So all those elements I mentioned earlier, tagging, control, and data, how do we gather the data? How does that feed into learning and development, leadership? And I'm afraid to say, in the midst of all this, everybody's got a day job. You know, they want to run something, prepare something, which hopefully keeps the business going. So the culture that sits behind this has to be very, very good. We can focus on risk control and safety critical elements. That's where process safety starts. And it does, I think, in many areas, not just process, but as I say, construction, manufacturing, buildings. Integrate and share information, decision making. Know where that data is coming from and how important it is. And part of that data goes to these leading indicators of failure. They have to all be linked to the hazards and the safety, but we've got to get the data to know that it's well. We build a safety culture that respects process and, in my view, individual occupational health and safety and the well-being. It's no good having the best operator in the world who in theory is most competent if he's not in a very good place to work. Whether it's fatigue, whether it's stress, whatever. Just like I don't want a pilot of a plane to be stressed. I don't want my operators stressed. Ensure competence and continually communicate. Let's break it down. Health and safety executive tends to take hazard and hazard identification, then move it into saying there's got to be in this organization knowledge of what it terms the RCS, the risk control system. So this is something now that ties together these elements of hazard and control and mitigation. Know the hazards, the pathways to harm, and the major accident scenarios. So it's fine me saying, I've got an awful lot of hydrocarbons, bit of liquid, bit of gas on this plant under a fair degree of pressure. Need to go a little bit deeper than that in terms of knowing our hazards, where they are, what they are, how can they be, what are the pathways to harm, whether it's a pressure vessel failure, whether it's a leak in ignition. As we move down that route, we get to the major accidents. But it tells you, it reminds you, please, when you do this, capture the primary causes of failure. Understand what starts that pathway, that initiator, as I call it, that moves a hazard that's contained and is relatively safe into a position where it's not. The oil in the deep water reservoir was safe until they punctured that reservoir and put a pipe into it. You know? If you then put enough controls on that pipe back to the ring, you're safe. There isn't a problem. When you start removing safety barriers, those safety critical elements, the risk rises at each step. And when you don't know what you're monitoring is telling you that it's not safe, then you have a major problem. List the controls and the critical safety system. It's a documented system. It needs to be detailed. This is detailed. This is not just I feel, I want, did you see? This is a recorded system. And out of those critical systems, primary causes of failure, using things like the fault trees, the event trees, the HAZOPs, and the studies that are done, then we can start to develop monitoring based on leading and lagging. So we still want lagging indicators, still want to pick things up that are problems. I still want to know my pressure relief valve wasn't set correctly when it was next sent in for refurbishment. Integrate with learning development to maintain competence. These are, I think, some of the absolutely critical things that would indicate a good system to me. And back to the hazards. The hazard just doesn't go from hazard to an incident, to a major incident, without going through a number of stages. There has to be, as I said, an initiator. In the center of this diagram is the pathway. That's the pathway. There are going to be, and there have to be, a level of barriers, whether it's observation by operators, pressure relief systems, pressure indicators, temperature indicators, flow controllers, whatever it is. Some of them will be operationally focused, some of them will be safety critically focused, so that the design is inherently safe. If my preventative barriers fail, then I'm going to get a loss of control. And I have to respect that that may happen. And therefore, I need a whole series of mitigation barriers. In Grenville, the initiator was a washing machine fire. The barriers that should have prevented that fire leaving that flat didn't work. They got a loss of control, fire affecting the cladding outside and smoke internally and fire within the flat. But I've still got my mitigation barriers. Sorry. I should still have the alarms, I should still have the escape routes, I should still have the fire teams, I should still be able to get people out. I may have lost the building, but God, I did not want to lose all those people. And so both sides of this equation are there. Now, my question to you is, if you can understand what the route is from the hazard to event, and I've got barriers, what do I know about the detection? Do I detect when a barrier is implemented, when it's forced? Or do I just assume, is it passive or is it active? If it's active, it tends to go bang, maybe, and I can hear it. Or it sets an alarm. But I want to know, how quickly can I detect? And the next thing I want to know is, how much time do I have between that initiator and that big bang for a process side of it? How long do I have between that washing machine catching fire and getting everybody out of that building? And what do I need? Are these barriers going to give me that time? Can I do it? How are the leading indicators? So time becomes important again. One of the great tools that I think came out of process safety was this thing called a bow tie. It's a simple concept, really, but what it did was it took an awful lot of early risk assessment, early quantifying and risk, and put it into a picture. And it said, if we can show the hazards and we can show the barriers and the controls, then hopefully we can understand what it is that's happening before we have the top event. Now, this is a simplified diagram. I've given you a little copy of what an actual bow tie may look like, depending on the software you use to do it. And here you can see some form of initiating with all the stages that might have to happen before that top event occurs. I think this one's probably based on a dropped object. It tends to be the one that things like Bowtie XP and others use. So you can see there's a range of different initiating events that lead into this. And what I want to know is that these barriers and detection work, so I can prevent it, I can stop it. But I also want to know, if it hits, then that the escalation and response also has mitigation barriers, and these are the ones that are traditionally shown across the right-hand side. So if I do drop a load, I don't want anybody standing, for example. Yeah, so there's a whole series of things I can do to prevent the worst impact of the realization of this harm that occurs. And all of this is documentation again. So my initiator follows a pathway to impact. That pathway has to have those barriers in place. And I think what's important is the time, but also the awareness of the hazards and the detection systems for the barriers. 3 questions for you to take away. How do you know if your safety barriers are working? And I don't care whether you apply it to driving your car, sitting in your flat in the evening, at your process plant, or at your construction site. The question still remains. Do you know what the safety critical elements and activities are? Do you know that what you've got in place to protect you is working? How do you know? And how would you find out if they're not? Do your inspections and audit allow you to check these leading indicators? Yeah? And are they linked to the safety critical elements? And finally, a personal plea, do you know how much time you have from detection of a problem to intervention? Because time is never on your side. In summary, whether it's operational, integrated learning, technical, it has to fit across both sides of this bow tie. Engage, support, learn, and improve has to be a motto that you take on board. Right, just a couple of minutes then, Leash, to run through what I think the future should be. Because I've probably covered far too much, far too quickly, and everybody's already lost. It's going to get a bit worse. I think there are major opportunities, not just for process safety, but safety in general. I'm aware that the Health and Safety Executive is trialing projects associated with what it calls artificial intelligence. But I believe that the future comes back to individuals, as individuals, but individuals sitting in a data world. We're probably at the worst part of this journey at the moment. We've got some information, we can access some information, but that information isn't really targeted to what we need, when we need it, and how we need it. This slide is based on a project I did in the client company a few years back, which was looking at the establishment of software, what could be done within this area. And it came out with a really nice idea. And it said, we can monitor the competence of this lady. We can know everything that she wants to tell us about her background, her qualifications, her experience. We know what the management system she's working in. We know her job. We know who she reports to. Her boss can see this as well. Why not? And when the management system tells her to do something, does she actually access procedures if she needs them, or policies? Well, we can make it easy for her. If there's complex jobs to do and she tells us I'm going to do this job, then let's automatically supply her that information. And when she's done that complex job, let's give her a tick in the competency box to say she's done it recently. So if she does it next week, that's fine. But if she does it in 6 months' time, maybe she just need a reminder of the risks. Oh, that brings it in, doesn't it? If I can do the procedures against an individual and a task, why can't I tell you this? Well, I can. There's no problem with that. And then somebody says, well, that's interesting, isn't it? Because if I go away on a week's holiday and I turn up on site, can it tell me what's happened? What do I need to know? What work is going on today that can affect my job? Yeah? Instead of me needing to know everything, it could tell me about my area, about my work responsibilities, about what's happening. Yeah, what a good idea. And so we can gather the data, we can put visualization techniques in for that, we can summarize and share the risks. We can link those risks to the tasks that you're doing. And if you want, you could go into a learning development program and see what the job was. Just as we all, when we're sitting at home wanting to do a job, go onto YouTube and say, show me how to do it, please, YouTube. Oh, that's good. Why can't we do this at work? We can. These systems are coming in, but they're at a very early stage of development. If I can plan the work and the work of your team and link it together, then my supervisor can see that. And I think this model is where the future is starting to move to. But we can't wait. And one of the things I would say is, you've still got to have the risks, you've still got to have the procedures, you've still got to have the data. We should be working on visualization, dashboarding techniques. We should be working on competence and helping people become more competent. And we've got to continually learn about how to get the best planning, aspects and supervision through this. So this is a summary of really what I've just been saying about this wonderful potential of the future. What if you turn up at work and see the information, the tasks that you have to do, on how to prepare, and how your tasks relate to other people, and the risks and the hazards and the barriers. Yeah? Rather than seeing it or reading it or being on a permit system, it actually shows you this is where you are. Check this, check that. Look at these leading indicators. Are they right? No, I'm not suggesting we're going to do this for every single job and task we do, but certainly if it's linked to safety critical aspects, we could easily start to do this. We know the knowledge and experience of team members. If you're the team leader, you can see who you've got. Yeah, Frida doesn't turn up today, but Bill does, and Bill has to do Frida's work, or vice versa. Then Bill can see why his competency doesn't match what Frida had. And you can help him. You can supply the information or the supervision. And you get feedback on completed tasks, and you know what's happening. I'm selling a world that doesn't quite exist, but keep your eyes open. It is coming, and maybe it will be available at some point in the near future. What I want to say is, look, thanks for listening. I hope I've hit the target about right. Apologize if I haven't. We do an awful lot of things in the hazardous industries group. We go quiet for a while, and then we have a bit of a rush. As a group, we can't get to it. We don't have the advantage of people like the group, the branches in Oman that have a personal relationship. So we rely very much on social media. Follow us. Join us on the IOSH LinkedIn. IOSH Hazardous Industries Group. Search LinkedIn. You'll see it there. I think we've got about 2,500 on that particular site. We've got about 8,000 to 9,000 registered members in IOSH and loads of contacts outside. And I'd certainly like to thank for slides I borrowed from OSHA. Then the oil and gas producers, I've produced a couple of their ideas, Institution of Chemical Engineers, AI Chemi in the States, the Australia one I mentioned. There's an awful lot of information out there. One of the things I will try and do tomorrow is put a little bit of a reference bibliography at the end of the slides before I issue them. So, Leash, over to you, sir. I think that's the end of everything that I want to say today.
Thank you, David. It's a great presentation, and I'm seeing the lot of positive comments in the chat box. Really, you nailed with your presentation. There are a couple of questions. With the, before that, there are a lot of appreciations. So great message. PSM is a fundamental. Great remarks. Process safety metrics. It's a great help. Great presentation. Can you share the presentation? Yeah, so the presentation will be shared to all, but unfortunately we cannot send you individually. So you have to go through the IOSH Oman webpage link. I have shared the link on the chat box, so there you can get the presentation. So David, a couple of you touched the great point that process safety is not limited to the process. It is it is building on the system. You give the great example of building and the car. You talk about the difference between the personal safety and the process safety. You talk about the pitfalls and the problems, the risk control systems, control at all points, the future. You nailed at all points. But there are a couple of questions. So the first question is, David, great message. PSM is fundamental. How are ensure the quality of PHA and QRA studies? There are many gaps among the different providers, and sometimes major hazards are missed. So what's your take on this, David?
Oh, so if I can summarize, what we're saying is that there's a wide range of studies. Quality of the studies can vary. A lot depends on who does it, when they do it. And to a certain extent, how can we overcome some of the weaknesses? Is that what you're saying?
Yeah.
Well, I mean, I hit hazards because I know that so many processes have them at the start. And I mentioned this business that there doesn't seem to be good systems for capturing the thinking and the process there and running it forward. It's equally the same when we do fault trees, event trees, and risk assessment. We don't seem to be able to pull out that summary. I think in terms of quality, one of the biggest problems that you've got is you've got to go back and ask a fundamental question. Are the people doing the studies competent? Did they hold the information? And at the time they did that study, are the parameters, if you like, that envelope around the design of what they did, still relevant today? Because as I mentioned, nearly every plant and process changes over time. So even if you go back to my little example of Grenville, if the Grenville Tower fire had occurred in 1990, very few people would have died. We'd have never heard of it. I'd have been amazed if anybody. What changed was the adding of environmental cladding outside. That was a major change to that design intent of that building. And yet nobody updated. Let me put it back into a process plant. You know, I add a heat exchanger, I add a fractionator, I change the feedstock, I change the product, I change the, the distillation column designs. I make changes. So when I go back to look at the risk assessment that was maybe done 3 or 4 years ago, it's got an awful lot of valid information, but actually, how relevant is it to where I am today? Does it tell me what conditions that were in place there at that time? And I guess I had the opportunity as a young engineer to work on a wide range of projects and with some very senior people who were very experienced. And I learned a very good lesson one day when somebody came into me and said, there's this project to increase throughput. Yeah. Did you know this was the original design of the plant? And he showed it to me. And it showed the very good reason why we couldn't do what we wanted to do without significant engineering change. I think the challenge is more about how we capture that information. And I sympathize with the person asking the question. It isn't difficult. It isn't easy. It's very difficult to do that.
Thank you, David. And I think you covered in the risk management, optimization, where you talk about the competence of the people, the risk management, the team, which is team working, the leadership, learning and development, the data control of activities. So and you're right. The competence of the people is very important. Who does this? Where he does this? And if we focus on the pitfalls, what you identified in terms of time, risk, awareness, yeah, that's really very crucial. So the next question is, it will be helpful to have a KPI for Tier 4 PSE, knowing it is leading indicator?
Sorry, a KPI for?
Tier 4 process safety incident, process safety engineering, knowing it is a leading indicator.
Do you mean sort of as you break down process safety into the individual areas, get KPIs and acceptable levels? Well, there are in many areas. You can see this sort of breaking through. One of the most obvious is where you get into instrumentation and you get safety integrity levels. Yeah? Safety integrity levels are designed to look at, if you like, the probability that an instrumentation system will operate when it needs to. There's no good me putting in a pressure control system as part of a safety design if it isn't going to function. And so safety integrity levels actually set levels there and rate them against the probabilities of success or failure. So an instrumentation or a component level, you can do that. You can look it up. As you come up the scale into the hazards and safety barriers and areas there, then it starts to become more a question of how important those are to an individual plant and process. Now, there's a lot being written on leading indicators, KPIs. And so what I'll do is I'll try and add to the bibliography a reference to the latest thinking on that, particularly from the Health and Safety Exec.
That will be really great, David. There are a couple of more questions, but due to the time, limitations, I'll share the questions to you, David, later, and we'll get it, updated on the IOSH Oman webpage. So thanks, David. Please stay with us, and I'll just take the updates. That as a IOSH Oman branch, we do these events on every 3rd Wednesday. And our branch events are based on the IOSH competency framework, which is the helping members on developing technical, core, and behavioral competence. We do in terms of the standalone presentations, CPD, IPD sessions, and the panel discussions. So our next events, I request everybody to book your calendar. So next event will be on the 19th of October, where we'll be talking on the environment awareness, air environment. Why should we care? We have a Dr. Jasmika. She'll be joining from UAE. We are also supporting the 6th Oman Fire Safety and Security event, which is on 25th and 26th October. And there is a special discount for the IOSH members to attend this, this conference. The next event will be on the 16th of November, where we have two major topics. One is on the cultural change and well-being, and the another topic will be from the Vice President OQ, which will be publicizing through our committee mailer. Just to remind all of you that the IOSH Council election is out. You have opportunity to elect 12 members, and I urge everybody to use your right to vote and help the right members to come on the council. Happy to share that recently I came on board on council, and I'll be attending my first meeting on the 11th and 12th of October. And I request everybody to vote, use your right to vote, and participate in the IOSH election, council election. IOSH has also opened up the research fund. So if anybody experienced researcher, if they are looking for any sort of help, please keep watch on the IOSH website, and you can apply for the IOSH Research Fund. You'll be getting full details on the IOSH website. IOSH is also looking for your feedback because IOSH has commissioned the survey with the Young Foundation with the different 11 other professional bodies. So give your inputs to the IOSH for helping the IOSH better understanding of occupational safety and health professionals, and what the professionals are facing and how actively we can work to address their issues. November, you will be having a good news that IOSH is coming up with a new blueprint, which is updated version of the existing blueprint. So the current blueprint will be replaced by the new blueprint, which will have the self-assessment tools, which also have the strength and areas of improvement, so which you can use to map your self-assessment, you map your competency framework, and develop your personal development plan. So you have the self-assessment, you have a strength and area of improvement through the different technical, core, and behavioral competencies, and you can also develop your personal development plan at one place. So look forward for this IOSH blueprint, which will be launched in the November 2022. And that will have the CPD resources. There you can record your CPDs, and IOSH is also going to mandate the IOSH ethical practice for the occupational health and safety professional, which is any OSS professional can go through, but it will be mandatory for all the chartered members and the chartered fellow members. Please use the IOSH mentoring system, where if you are an experienced qualified person, you can be as a mentor, or if you are looking for the help for your professional growth, for your career development, then you can join as a mentee. So as a mentor-mentee program, it is a very good platform to exchange the experience and information. So please make use of this. So with this, let me give thanks to, on behalf of IOSH Oman Committee, all the attendees. We had more than 200 members attended today. Thanks to David for your excellent presentation. Everybody is looking forward to have the copy of the presentation. I'm sure we'll be sharing this, and even people will be looking forward again to have the video recording, because I have a lot of personal requests that we want to have the video recording access as well, so that we can hear the David again and again. So thank you, David, on behalf of IOSH Oman Committee and all the attendees for your great support. I know in the short time you accepted our invite, and you given a very great presentation. So as a token of thanks, we'll be sending you this certificate.
Thank you.
And you'll be we'll be looking forward for your more support in the future events.
You have it.
Hope IOSH Oman and the hazardous industry group will have more collaborative sessions in line with the IOSH objectives. So as IOSH Oman, we also do the member support. So if any of you, if you are around in the IOSH Oman membership And if you are looking for any membership support, you can reach out to any of our committee members. We are very, very happy to support you. So once again, thank you everyone for joining today. Immediate after this, session, you'll be having a pop-up with the, survey link. So please spend few minutes on this survey and give your feedback that how this session was, how we can improve, and what are the future, topics you are looking forward. So we are looking forward for your feedback on this, post-event survey. So give your valuable feedback. And once again, on behalf of IOSH Oman and the Hazardous Industry Group and the IOSH, thank you everybody for joining us, and we'll see you on the next session. Thank you.